Hello, Math 141. We want to have a few examples of solving exponential equations. A couple of these problems were emailed to me, and a couple of them are coming from my old notes. First one, suppose we have 5 to the power of x to the second plus 8. And that equals 125 to the power of 2x. Okay. So what I'm going to do here, I'm going to notice that 125, in fact, is 5 cubed. So I'm going to rewrite this as 5 to the power of x squared plus 8 equals 5 cubed to the power of 2x. And now 5 to the power of x to the second plus 8 equals, now here notice that I have power of power, so this is the same as saying 5 to the power of 3 times 2x, which is 6x. And now remember that this equal sign right here, arguably the most important sign in mathematics, this equal sign demands that if the left-hand side, if the base on the left-hand side is the same as the base on the right-hand side, then the power on the left-hand side equals the power on the left-hand side. So what I'll do, I'll just go ahead and drop the base since it is the same and claim that, okay, x to the second plus 8 equals 6x equals 6x. Okay, my iPad is acting up. Let me go ahead and go to the next page and continue from there. So x to the power of x to the second plus 8 equals 6x. So I'm going to write this as x to the second minus 6x plus 8 equals 0. And yes, this is factorable. X minus 2, x minus 4 equals 0, and x equals 2, and x equals 4. So the solution set is going to be 2, 4 is the set of solutions for the given problem that we have. Let's do one more. Suppose I have 4 to the power of x times 2 to the power of x to the second equals 16 to the power of second. So first thing I'm going to notice is that 4 is a power of 2, and of course 2 is power of 2, and 16 is power of 2. So I'm going to rewrite this as 2 to the second to the power of x times 2 to the power of x to the second equals 2 to the power of 4 for 16 to the power of 2. And I have power of power in here and in here. So I'm going to rewrite this as 2 to the 2x times 2 to the x to the second equals 2 to the power of 8. And here on the left-hand side, now notice that I have the same base. So I have to keep one, keep the base and add the power. So 2x plus x to the second. that equals 2 to the power of 8. Okay, so let me go to the next page and continue there. So I have 2 to the power of 2x plus x to the second equals 2 to the power of 8. Once again, this equal sign demands that if the bases are the same, then the powers must be the same. So I'm going to rewrite this as 2x plus x to the second equals 8. So what I essentially did, I dropped the bases. Okay, well, I can do better than that. I can rewrite this as x to the second plus 2x minus 8 equals 0. And it is factorable to x plus 4, x minus 2, and equals 0. So x equals negative 4 and x equals positive 2. So the solution set is negative 4 and positive 2. Okay, nothing too hard so far. Let's do one more. How about 9 to the power of 2x times 27 to the power of x to the second equals 1 there. Okay. So I see 3 all over this problem. Here's what I mean. I can rewrite the first term as 3 to the second to the power of 2x times 3 cubed to the power of x to the second. And on the right-hand side, 1/3 is the same as 3 to the power of negative 1. So here I have power of power in here and in here. So I'm going to change this to 3 to the power of 4x times 3 to the power of 3x to the second equals 3 to the negative 1. And now here I have the same base being multiplied. So this is the same as 3 to the power of 4x plus 3x to the second equals 3 to the power of negative 1. So what I'm going to do here, I'm going to go ahead to the next page. And first of all, before I go to the next page, remember that this base is the same as this base. And once again, this equal sign demands that if the bases are the same on both sides, then the powers must be the same. So let me go to the next page and rewrite this as 3 or 4x plus 3x to the second equals negative 1. After dropping the base, I can rearrange this to 3x to the second plus 4x plus 1 equals 0. Okay. All right, I need two terms that multiply to 3x to the second. How about 3x and x, and two terms that multiply to 1? How about plus 1 here and plus 1 here? Let's see. 3x squared plus 3x plus 1x is 4x. Yes, this is correct factoring. Setting this equal to 0, 3x plus 1 equals 0 results in x equals negative 1 there, and x plus 1 equals 0 results in x equals negative 1. So the solution set is negative 1 there. And let's do just one last one for the sake of practice. Suppose I have e to the power of 4x times e to the power of x to the second equals How about e to the power of 12? Okay, so here I'm gonna have, so this is same base, so e to the power of 4x plus x to the second equals e to the power of 12. So same base, drop this, I get x to the second plus 4x minus 12 equals 0. And why is that? Because from here, if you drop the e, you would get 4x plus x to the second equals 12. So subtract 12 from both sides, put them in order from highest power to the lowest power. And let's say, let's factor these to x plus 6 and x minus 2 equals 0, and x equals negative 6, and x equals positive 2. So the solution set for this given problem was negative 6, comma 2. Hope you enjoyed these examples. Talk to you soon. Thanks.